Space is vast, really vast. It's so immense that it boggles the mind, stretching out in all directions, seemingly infinite. Light, the fastest thing we know, takes years, centuries, even millennia to travel between stars. This incredible speed is still not enough to bridge the vast distances of the cosmos in a timely manner. This poses a fundamental challenge for intergalactic communication. Scientists and engineers are constantly grappling with this issue, trying to find ways to overcome it. Imagine sending a message to a distant galaxy and waiting millions of years for a reply. The sheer time involved makes it impractical for any meaningful exchange. It's a cosmic conversation killer. The delay is so long that any real-time interaction is impossible, making it feel like talking to a ghost. Traditional communication methods, reliant on radio waves crawling across the cosmos, simply won't cut it. These methods are outdated and inefficient for the scale we're dealing with. We need a radical new approach, something that transcends the limitations of space and time. Innovative technologies and groundbreaking ideas are essential to make this a reality. Current methods rely on radio waves. These waves, while effective over short distances, are not suitable for the vast expanses of intergalactic space. These waves travel at the speed of light. Even at this incredible speed, the distances involved mean that messages take years to reach their destination. Even at this speed, messages take years to reach other stars. This delay is a significant barrier to effective communication. This makes real-time conversation impossible. The frustration of waiting for a response that may never come is a major hurdle. The vast distances involved make traditional communication impractical. We need to think beyond our current technologies and explore new possibilities. For intergalactic communication, we need a new approach. This approach must be revolutionary, capable of overcoming the immense distances and time delays that currently hinder our cosmic conversations. Enter quantum computing and holography, two revolutionary technologies with the potential to shatter the intergalactic communication barrier. Imagine a future where messages travel across the cosmos in the blink of an eye. Quantum computing harnesses the bizarre laws of quantum mechanics to perform calculations at speeds unimaginable for classical computers. These machines use qubits, which can exist in multiple states simultaneously, unlike traditional bits. Holography, on the other hand, allows us to store and retrieve information in three-dimensional patterns using light. This technology can create lifelike images that seem to float in midair. Together, they hold the key to a future where communication across galaxies is as instantaneous as a chat with your neighbor. Quantum computers use qubits, which can exist in multiple states at once, enabling them to process vast amounts of data quickly. Qubits can exist in multiple states at once, a phenomenon known as superposition. This allows quantum computers to solve complex problems that are currently impossible for classical computers. This allows them to perform complex calculations quickly, revolutionizing fields from cryptography to material science. Holography uses lasers to record and reconstruct three-dimensional images. These images can be used for everything from data storage to medical imaging. These images can store vast amounts of information, making them ideal for archiving and retrieving data in ways we never thought possible. At the heart of this revolutionary communication system lies quantum entanglement, one of the most mind-boggling phenomena in physics. Quantum entanglement defies our conventional understanding of space and time. When two particles are entangled, they become linked in a way that transcends distance. This means that no matter how far apart they are, they remain connected. Any change to one particle instantaneously affects the other, regardless of whether they're separated by millimeters or millions of light years. This phenomenon is not just theoretical, it has been demonstrated in numerous experiments. This instantaneous connection forms the backbone of our intergalactic communication network. Imagine two particles linked. This connection is unbreakable and instantaneous. Change one, the other changes instantly. This connection ignores distance. This is entanglement. It's as if the particles share a secret handshake that no distance can disrupt. It's key to faster-than-light communication. This technology could revolutionize how we send information across the cosmos. By entangling particles across galaxies, we create an instantaneous communication channel. This could enable real-time communication between distant star systems, making the vast universe feel a little smaller. But how do we encode and transmit information using entangled particles? This is where holography comes in. Instead of relying on traditional bits, which can exist in only two states, 0 or 1, We can encode information in the complex, multidimensional patterns of holograms. These holographic patterns are then projected onto entangled particles which act as instantaneous carriers of this information across vast cosmic distances. Holograms store information in multiple dimensions. This is more efficient than traditional bits. These holographic patterns can be encoded onto entangled particles. This allows for complex information to be transmitted instantly.